to hear, to read. Of course, I'd like to inform that this event is live streamed on YouTube. So we are taking permission. It's going to be on YouTube so that we can always go back as a resource to read, engage, learn, relearn, and unlearn. Distinguished guests, ladies and gentlemen, once again, welcome to the monthly technical meeting organized by SPE Abuja section. Every month, as it's done with SPE, we share technical knowledge to all of our members, and we say a warm welcome on behalf of the leadership of SPE Abuja section. Of course, you can see on your screen, we have the agenda. This event starts arrival of participants. Then we have a safety brief. After the safety brief, we introduce some of our VIPs on call. We'll have a welcome remark by our section chair, and then we introduce the amazing speaker. And after that, he would have the opportunity to speak to us for about 40 minutes. After his 40 minutes technical lecture, he has about 10 minutes to respond to your questions. We kindly appeal that when he's speaking, you can drop your questions on the chat box so that he can respond to them one after the other. After that, we'll have a closing remark. And of course, networking. It's going to be a very brief, it's going to be very interesting. And of course, it's going to stimulate all of our brains. Continuing, let's have the safety brief. We appeal that if you're not speaking, you leave your microphone on mute so that you do not interfere with the deliberations we'll have today. If you want to speak, you can raise your hands up and you will be given permission to speak. You can also use the chat button for your comments and your questions. We also advise that for those that are driving back home from work, please use the Bluetooth device on your vehicle. Do not hold the phone while driving. Ensure you can still hear the fire alarm with your headsets on. And of course, stay safe. We'll continue, ladies and gentlemen, by recognizing some amazing personalities that have joined us on this call. We'll start by saying a warm welcome to our section chair, joining us all the way from Tanzania. A very, very good afternoon to you, sir.
Thank you so much, Afan, and thank you for the call.
Okay, thank you so much, sir, for joining us even when you're out of the country. We say a warm welcome to our amazing speaker. Of course, he is a research fellow from the Department of Chemical and Environmental Engineering from the University of Nottingham. A very warm welcome to Dr. Diren Tangen. Welcome, sir.
Yeah, thank you very much. Yeah, thank you, sir.
We say a warm welcome to all of us senior members, professional members on the call. I've seen Ayomide on the call. I've seen Oluwadamilola from Fotimin on the call. We've seen Simon Adamu on the call. We've seen quite a lot of professional members. Mishek, welcome. Lokman, welcome, welcome, welcome. Thank you for joining us today. And of course, you're going to learn so much. We continue the event, ladies and gentlemen, by listening to our section chair. It's a pleasure to welcome Engineer Ikechukwu Okafor, PhD, as he gives his welcome address. Section chair, the stage is yours, sir. Professor, okay.
Confirm you can hear me.
Yes, we hear you, sir.
Okay. My welcome address is quite brief because not as long I got but you always dial back to what our section part of that section.
Yeah, we are hearing you, though it's lagging, sir. We can continue.
It is lagging.
You can go on, sir. Go on, sir. We are hearing you.
Okay. Everyone on behalf of SP Abuja section, the board of SP Abuja section, I want to say Warm welcome to all of you. A special welcome to our speaker for today, Dr. Direct Tangan. Thank you for accepting to speak to us. Thank you for accepting to share knowledge, because knowledge becomes a waste when it's not shared. Thank you for wanting to open our eyes to the possibilities that abound. Right. SC Abuja is committed to sharing the value, the core values of the national, which is technical dissemination of knowledge among members, especially to teach them the things where they are aware with the innovation and solutions that abound in the industry. In SC Abuja, we take things like this very valuable, because it's an opportunity to learn, and learn. So I want to say a warm welcome to everyone who has joined, for those who joined. And thank you, and let's have a wonderful day. Thank you.
Thank you so much, Section Chair. In his words, knowledge is a waste when it's not shared. And so we are grateful to our fellow from Nottingham University who has decided to share knowledge with us today. Of course, today's presentation explores the emerging use of microwave technology as a revolutionary method for cleaning up oil spills. Unlike the traditional techniques that can be time-consuming, costly, and environmentally damaging, microwave-based remediation offers a faster, more efficient, and an eco-friendly alternative. This session delves into the science behind how microwaves break down and rise oil residues, the benefits of our conventional, mechanical, and chemical methods, and the practical applications in both marine and terrestrial spill scenarios. Real-world case studies and pilot projects will be examined, highlighting the technology's potential to transform oil spill response and environmental protection efforts globally. Of course, to take us on this very interesting topic is Dr. Direct. Of course, he holds a BNG and an MENG degrees in chemical engineering from the Abubakar Tafawa Balewa University, Bauchi, Nigeria. He obtained an MSc in environmental engineering from the University of Nottingham in the UK, where he also completed his PhD in chemical engineering under the sponsorship of the Petroleum Technology Development Fund, PTDF. During his PhD, he represented the University of Nottingham and won the 2023 Global Universitas 21 3-minute thesis People's Choice Award with his innovative research focused on the application of microwave processing technology for the remediation of petroleum polluted soils. His expertise includes microwave processing of materials, soil remediation, biomass processing, waste recycling, and valorization and process optimization. He is a registered engineer with the Institute of Chemical Engineers, ICHEME, of course, the Council of Regulation of Engineers in Nigeria, COREN, and the Nigerian Society of Engineers, NSE. Dr. Tangan is currently a research fellow at the Department of Chemical and Environmental Engineering at the University of Nottingham. His research focuses on innovative applications of microwave heating technologies in various sectors, including steelmaking, food, energy, and catalysis to help decarbonize these sectors. In addition to his research work, Dr. Direct serves as the General Secretary of the Nigerian Society of Engineers Glasgow branch in the UK, demonstrating his commitment to the engineering profession. Your Excellencies, ladies and gentlemen, the next 35 to 40 minutes we'll be listening to a research scholar, of course, from the Department of Chemical and Environmental Engineering from the University of Nottingham. Help me welcome Dr. Diren Tangan. Doc, the stage is yours.
Yeah, thank you so much for this wonderful opportunity. I count it a privilege to share part of my work with you all on this call. and to as many as would be learning from it in the future. And I thank the leadership of the SPE Abuja for giving me this privilege to talk about cleaning up oil spills with microwaves, a faster, smarter solution. In just a minute, I'll be sharing my screen and start up with the presentation. Yeah. All right. Yeah. Can you all see my screen now? Can you hear me?
Yes,
All
I
right.
can
Yeah.
see you.
Yeah, thank you. Thank you so much. So once again, I'm thankful to the leadership of the SPE for this great opportunity, and I would like you to follow on with this discussion. Hopefully, you will be blessed that you are part of this call this afternoon or evening, depending on wherever you are joining the call from. So today I'll be talking about cleaning up oil spills with microwaves, a smarter and a faster solution. And in this presentation, I will be introducing some keywords just to carry all of us along. Whatever your background is, you should be able to follow the presentation. As well as I'll be giving an introduction, the passion behind this particular work, as well as why microwaves. Why are we exploring microwaves for oil cleanup? From contaminated land problems. And then I will also take you through part of the methods that I have used in my work, as well as present a few results and draw key conclusions, and also give us a taste of what it looks like in terms of scale up concepts of scaling up this particular type of research. All right. I'll be using these keywords, and I wish to just simplify them so that all of us will be able to follow on. So, one, we are talking about land contamination, and precisely land contamination is simply the pollution of land surfaces, rendering them unfit for purpose. So, it could be a land that is meant for agriculture, but pollutants have been introduced upon that land, thereby rendering it unfit for purpose. It could be a land that was meant to be used for housing and redevelopment, but then it's not fit for purpose because it's contaminated. And this is a typical scenario of contamination that we have seen over and over in the Niger Delta in Nigeria. And particularly, I will be focusing on a pollutant called the total petroleum hydrocarbons. And total petroleum hydrocarbons simply comprises the aliphatics, which means from carbon chain C10 right up to carbon chain C40. Another 16 priority polycyclic aromatic hydrocarbons. So those range of hydrocarbons constitute what we call the total petroleum hydrocarbons. And they are going to be the key pollutant that actually renders the land or the soil unfit for purpose in this context that I am talking about. And then the goal of remediation is actually to restore that polluted land and make it fit for purpose or for disposal as well, depending on the end goal of the remediation exercise. So there are actually different approaches in remediating contaminated land, contaminated soils, or contaminated solids. And these can be classified in different ways. You can find these classifications done in different ways by different authors. But however, I wish to summarize it simply in this form. We have what is called the physical-chemical methods, such as soil washing. And this method actually leverages on the physical-chemical properties of the contaminant as well as the soil to then separate them from each other. And a particular example is soil washing, where you separate the soil based on their particle size. Those with very smaller particle size tend to absorb more of the pollutant. And then you've been able to concentrate the material or concentrate the pollution within a certain particle size. And in that way, you can then wash that concentrated part of the material using different solvents. And it could be water. And as well, this has to go along with a kind of recycling of the water or post-cleaning of such water or solvent that is used for this purpose. We also have what we call the chemical methods. And these methods actually employ chemical reagents to either transform, destroy, or concentrate contaminants in order to restore the land or the soil and make it fit for purpose. And we have the biological methods such as the bioremediation and phytoremediation using plants. And basically what these do is that you use living organisms to feed on the contaminant in the soil. And as they feed on that, they break it down and make it into a less toxic form, and thereby getting the land fit for purpose. And also, we have what is called the thermal methods, which I'll be focusing on more today. And a typical example of that is the thermal desorption, which is the conventional heating system where you get to heat up soil materials just to get rid of their contaminants. Sometimes there can be different examples of thermal methods. One of which that uses very high temperatures is what we call the incineration method, which kind of destroys basically whatever the contaminant is. But today I will be presenting a smarter way of remediating such soil materials other than using incineration of very high temperature within the thermal methods. And I'll be talking about that much later. So what they do is that they kind of help increase the contaminant phase vapor pressure, thereby making it easy or promoting vaporization of the hydrocarbon within the contaminated material. And then lastly, on this classification, we have what is called the civil engineering methods. And what that actually do is that if you have a source of contamination, and then you have a receptor. Receptor is whatever is being affected by the source of the contamination. We can term that as a receptor. And what remediation does is to try and cut the linkage between the source and the receptor. And what civil engineering methods try to do is that they create a barrier between the source of the contamination from getting contaminated by the source. And they use things like containment walls, or it could be excavating that area, that source that is contaminated, and then landfilling it somewhere safe that can be properly managed. So microwaves are basically from the electromagnetic spectrum. I guess some of us are familiar with the electromagnetic spectrum, where you have different regions across different frequencies and wavelengths. And so microwave exists between the radio frequency and the infrared waves as well within the electromagnetic spectrum. And microwaves basically are ranging between 0.3 gigahertz to about 300 0.3 to about 300 gigahertz of frequency within the electromagnetic spectrum. And many of us would actually have heard of microwave in terms of telecommunication application, in terms of communication in our mobile phones and other things. But today we're going to be looking at it precisely from the heating application approach, whereby these high frequency electromagnetic waves are being applied to heat up materials. And the major governing equation behind the whole principle is this equation, where we have the PD, which is the power density. And actually that explains or describes the power absorbed by unit volume of a material. So it is the power absorbed per unit volume of a material, and this is actually directly proportional to the frequency at which the microwaves are being used, as well as what we call the dielectric properties of the material and the electric field strength where the whole material occupies. So if you want to get a high power density, we try to play around with the electric field as well as the frequency within the whole system. Now, not all materials are heated using microwaves. But the materials that get heated using microwaves are materials that have good dielectric loss factor, and which means that they're able to absorb microwaves more and dissipate heat in the process. And so for this technical session, I'll be giving us a case study with the research that I did during my PhD under the supervision of Dr. Lino, Dr. Mohammed, and Professor John Robinson here at the University of Nottingham. And I'm thankful to the PTDF for sponsoring this research and the University of Nottingham for giving me the lab space to carry out this research. All right. The rise in the world's energy demand has led to a corresponding increase in oil and gas exploration activities. And during these processes, crude oil spillages or their refined products occur, leading to major environmental problems such as land pollution. We all know that the Niger Delta is the home to Nigeria's oil and gas reserve, and this region itself has suffered the impact or the effect of oil pollution for about 6 decades of oil and gas exploration activities within this region. The Niger Delta contributes up to about 75% of Nigeria's foreign earnings, which means that Nigeria largely depends on the gains from the oil and gas activities within this region. However, in 2011, the United Nations Environmental Program conducted an impact assessment to see the impact of the oil and gas exploration activities within this region. And their assessment revealed an urgent need of the cleanup and the remediation of this rich bioresource region. Nigeria's Federal Ministry of Environment estimated the level of contamination of oil within this region to be about 9 to 13 million barrels of oil spillages. And to put that in context, this is equivalent to the oil consumed in the UK for over a period of 8 days. And this has impacted the lives of over 31 million inhabitants of that region, whose major employment used to be agriculture, food production, and fisheries. Chikere conducted a research within this region comparing a pristine soil, which is a virgin soil that has not been contaminated with oil, as well as a site that has been contaminated with oil. And you can see from his findings in Table 1, a massive increment in total petroleum hydrocarbons from about 200 milligram per kilogram to about 7,600 milligram per kilogram. And this showed that total petroleum hydrocarbons, which I had defined earlier, is the major contaminant within this region. And you can see clearly that this exceeds the limits, the acceptable limits set by the environment industry within Nigeria, a GASPIN, which is about less than or equal to 5,000 milligram per kilogram. So this is just the acceptable limit of oil spill that the oil industry considers safe. But this exceeds it a lot, and therefore is the focus of this particular research. Now, although the government of Nigeria launched a cleanup exercise, which is the Ogoni cleanup in 2016, there was, however, no recommendation as to what technology will be the best in terms of cleaning the oil spills within that region. It is, however, clear that this is not going to be a one single technology solution. It's not a one-size-fits-all approach, because that wouldn't be appropriate, because different sites have different characteristics. They have different level of oil contamination. They have different types of soils. They have different other properties, like how much of the oil has been spilled in that region over how many years. So you don't actually expect that one technology will be the ultimate solution. Generally, we think that it's going to be a combination of different technologies, and that's why I started initially by introducing the different categories of technology approach in solving land contamination problems. And that is actually going to be what will proffer a more efficient solution to the problem in the Niger Delta. However, one technology solution is microwave heating. Why microwave heating? Now, when you look at figure 5A, you can see a comparison between a conventional heating system and microwave heating. Now, on the left side of figure A is an illustration of a conventional heating, which is the normal heating we are used to, maybe how you cook your food using your electric cooker or your gas cooker. What happens is that you hit one end of the pot or one end of the material, and the heat is transferred from that end to the other parts of the body. So from outside to the center of the body by conduction. That is the principle of a normal conventional heating. However, in the case of microwave heating, you can see that it heats differently. It heats all the particles. So if, for example, you're cooking your food, the microwaves heat all individual particles at the same time, other than the conventional heating that starts heating from one end and then transfers the heat to another end. So you can see that the microwave heating occurs by heating the material selectively within its volume, and therefore is a more efficient way of heating. And the microwave has the following advantages over the conventional heating system, which are: it is selective, which means that it delivers energy directly to microwave absorbing bodies. So when we bring it to the context of a polluted soil, we know that we have the polluted soil which contains moisture. Soils have moisture content, and at the same time, because it's contaminated, it now has hydrocarbons on it, which is from the oil. Now, the hydrocarbon phase within the contaminated soil is a poor microwave absorber. So which means that if we want to heat the oil itself, it might be a bit difficult or challenging to heat the oil directly. So what this smart technology does is that it leverages on the selective heating of the moisture that is trapped within the soil pores, because moisture itself is a very good microwave absorber. It has a very good dielectric properties, and similarly, all polar compounds generally have good microwave, are generally good microwave absorbers. And in this case, we selectively target the moisture using microwaves. So as you heat the microwave, the soil moisture within the soil particles or the soils, moisture is rapidly converted into steam. And you know, the steam is then trapped within the pores of the soil. So what happens is that as the steam forces its way out of the soil pores, it then strips off petroleum hydrocarbons. And these hydrocarbons could as well be collected separately, recovered, and used as fuel in terms of application on larger scales. So it's very selective. It targets the moisture to heat the entire system. And that's the same principle when you're microwaving your food in your kitchen microwave. And as a result, because of the type of heating of microwaves, it is actually energy efficient. Microwave also heat volumetrically, like I've explained. It heats every spot at the same time rapidly, rather than heating from one end to another. And this makes it easy because you can get to heat a high volume of material within a shorter period of time, within a shorter period of time. And that it's a great benefit when it comes to the scale up of such a technology, because for a particular process, it's going to be an advantage in terms of reducing your plant footprint. So the capacity of or the scale of the process itself will be reduced when you're using microwave technology as compared with when you're using conventional heating. So you get small footprint using microwave heating. And also it has low thermal inertia, which means it minimizes long heat-up periods as well as thermal gradients, and it minimizes heat loss when compared with conventional heating system. It's very easy to start up and to shut down. It's just a button. Once you touch the button, it starts and it heats rapidly. And once you're ready to stop and you push a button, it stops. And you know, it doesn't have to heat the entire system. So when you're cooking your food, for example, using your electric cooker or gas cooker, the whole system gets heated. But when you're using your microwave oven, it is the material that you are targeting that gets heated. So the focus of the energy is targeted directly to the material you're trying to heat, compared with the conventional heating that requires more energy and also loses more energy in the system. And last but not the least, very important, microwave heating is electrically operated, which means that with a transition from fossil fuel to renewable energy, we can actually power microwave systems using renewables rather than focusing on fossil fuel. So in this particular research, we collected samples of contaminated soils, 4 different samples of soils from different sites, 2 of them here within the UK, and then 2 of the soil materials within the Niger Delta. And we first of all characterized the materials. After preparing them, we characterized them to know the amount of moisture in these materials, which is what we are targeting, as well as the amount of oil within the material, because it would be good to know the initial oil before the treatment, which would then be compared with the final oil after treatment. Now, in this particular research, we use 3 different technology approaches. One is using what we call the dry heating system. Now, the dry heating system actually involves heating the material as received without any modification, whereas the wet microwave heating system involves wetting the material with good microwave absorbers or susceptors to enhance further oil removal. And that is also compared with what we call the liquid inert system, whereby the contaminated soil material is immersed in a microwave transparent solvent. So transparent in this case means that that solvent, it doesn't absorb microwaves. So it means that you will be able to target the material that is inserted into the solvent directly without the effect of the solvent within which the soil material is immersed. So these are the 3 technology configurations that were compared in this particular research. To start with, the dry and the wet microwave heating system. So in this setup, we have the microwave generator, and particularly it is the 2 kilowatt generator supplying microwave energy right through the waveguide. So this direction or this channel is what we call the waveguide. And the waveguides are actually designed using materials that are microwave reflectors. So they themselves don't absorb microwave, but they then allow you to transport these microwaves from the generator right through your target, which is the material that is contained in this reactor. And once it hits the material, the moisture within the material is rapidly converted into steam. And as the steam forces its way out of the soil pores, it then gets rid of the oil within the pores and at the surfaces. And that oil is then trapped using condensers. And like I mentioned previously, on the scale-up side of things, you can get value out of the oil that is recovered. Now, this particular approach Both works for both the dry and the wet system, where the soil materials were weighted with microwave susceptors to enhance further removal of oil. And very high oil efficiency removal were obtained up to about 95% within this dry and wet microwave heating system. However, there was a challenge that was encountered in the process, and that is the problem of thermal runaway. Now, thermal runaway occurs when an increase in temperature within the soil material then changes the process configuration, thereby leading to an uncontrollable increase in temperature. And when that happens, it damages the equipment. And precisely, this is one of the major difficulties or the major challenge that has hindered the scale up of this technology for commercial application. And therefore, the next phase of the research has been focused on trying to overcome the problem of thermal runaway. And that leads us to using the inert liquid system, which I've explained. The microwave, the contaminated soil materials were immersed in a solvent that is transparent to microwave and then heated using microwave energy. The same thing happens, the same process. However, the solvent, because it's been immersed in the solvent helps to control the temperature within the system, thereby managing the problem of thermal runaway. And indeed, we're able to overcome the problem of thermal runaway using the inert liquid system, after which we collected the soil materials and then analyzed them for both oil content to then see how much of the oil has been removed from the initial oil content of the materials. Now, these are examples of the soils that were used for this purpose, both before and after treatment. We have the road planings and the filter cake, which are solids. I wouldn't really classify the first two as soils, so to say. Filter cake are usually a product of soil washing that concentrates more of the contaminant within smaller fine particle size material. So I will just classify these ones as solids. The first two road planings are from roadside works, all the coal tar, highly bituminous material with heavy oil constitute the road planings here. Now, this is how the material look before and after treatment. The last two soils are the materials collected from Bodo in the Niger Delta, as well as Kedere in the Niger Delta. Now, what were the key findings from this work? We're able to achieve oil removal using the UK solids, contaminated soils or solids, up to about 87% in less than 7 minutes. Also, filter cake achieved up to about 95% oil removal in less than 4 minutes. And for the Niger Delta soils, we applied the process of overcoming thermal runaway, which is using the liquid inert system to then apply that technology on the Bodo and Kedere soil. And we got up to 65% oil removal in 10 minutes for Bodo soil and up to 80% oil removal in 1 minute for Kedere soil. And these were actually below the standard set by EGASPIN of 5,000 milligram per kilogram. So we're able to meet this standard with the Niger Delta soil using the inert liquid system. However, using this system came with a trade-off, as high energy was then required to use to treat the soils, the Niger Delta soils, in the liquid inert system compared to that which was used in terms of the dry and the wet heating system. So, for example, at about 3 gigajoules per gram of energy supplied during the microwave treatment in the case of dry and wet microwave heating system, the equivalent to achieve the same oil efficiency was up to about 22.6 gigajoules per gram of energy in the liquid inert system. So that required higher energy because some of the energy is being dissipated into the microwave transparent solvent in the process. But comparing microwave heating with the conventional heating system, the amazing thing is that it was able to reduce the processing time by about 90%, and it only required a third of the energy used for that same to achieve the same oil removal efficiency in a conventional heating system. To give us an overview or an idea of how the scaling up of this technology would look like, these are a few works that have been carried out here at the University of Nottingham by Buttress and the team. I currently work within the team of Buttress. Robinson was my supervisor during my PhD, and this is a typical pilot plant for the decontamination of drill cuttings, which has a capacity of about 500 kilogram per hour throughput processing capacity, as well as the system by Buttress has a capacity of processing about 150 kilogram per hour of material. And when you look at the entire process in an industrial scale, this is what it's actually going to look like. You would have the soil, which is contaminated, being excavated and then loaded using a conveyor belt right into the system, going right through the microwave applicators where the microwave energy is being supplied using magnetrons. And it is at this point that the material is being heated with microwave, and you can see that there are actually gas collection systems whereby the evaporated or the vaporized hydrocarbons are being condensed and recovered, leaving behind clean soil at the end of the process. And then this is actually an ex-situ application. Ex-situ actually means that you are not doing the treatment on site, but rather you're digging the soil and then transporting it or moving it to the remediation site where you have your equipment, and then you treat the soil. After treating the soil, you then backfill the site where it was excavated. And there are other in situ approaches that were demonstrated by a few people at a pilot scale. We have the work done by Krausek, where he kind of focused on the contaminated site. He dug a well, introducing the microwave applicator right into the soil, where you supply microwave energy to the soil. It heats up the entire region here, and as the hydrocarbons vaporize, they are being collected using extraction wells and condensed and recovered. And similarly, they design like a mobile system where you have for subsurface oil cleanup, where you have the microwave system operating like a vehicle that drives along the contaminated surface, and as a result heats up the surface. And as it heats up the surface, the oil is being evaporated using the same system and then condensed and recovered as well. Now, however, this mobile system would be suitable just for subsurface cleanup where the oil contamination has not gone too deep into the soil. So this is actually an idea on how an industrial concept of the application of this technology is going to look like. These are a few references cited in this presentation, and thank you all for listening.
Thank you, thank you, thank you. I think our speaker deserves some visual applause. Thank you, thank you, thank you. I'd like to see your comments in the chat box. Thank you, thank you. And then it's time for questions. So please, if you want to ask a question, you can drop a comment or you raise your hands. So let's treat the comment. Once you are done treating the comment, we would attend to all of the hands being raised. The first question to you, sir, is from Tabji. After the heating and cleanup using microwave, will microorganisms and plants be able to grow on that land? If so, is there an estimate of the timeline? That's the first question. Okay, I think we should take all the questions so that you can answer all of them at once, right? So, okay, Publicity Chair, please unmute your mic and ask a question. After that, we'll have the section chair ask his, and then we'll have our membership chair. Publicity chair, please go ahead.
Thank
Your
you
question,
very
please.
much, presenter. This is a topic that is very close to my heart. I say that because I've worked in the pollution control team for many years. I have assessed several kinds of technologies for remedial action in impacted sites. So when you're talking of Kedere, Bidere, and all the Ogoni cleanup and all, I was part of those projects with SPDC, and also I have a very, very good understanding of not just theoretical application, practical, because I've been on site, I've been in fields and all. So thing is, this technology presented is the first time I'm hearing of this. This is the first time. So it piqued my interest. So I listened intensely throughout the presentation. So I have a few questions. One of my questions has already been asked. Does it energize the soil? Can life still grow on it? Can it still support life? Because that's one of the key things we look at when we are assessing technologies for remediation. Secondly, I think during the presentation you mentioned something about the volume. I want to know the batch. How much volumes can this a batch treat? Because you want to compare it with conventional treatment methodologies, and you want to see, okay, so this is like two questions in one. What advantage does it have in terms of amount of time and efforts in terms of cost now, and energy in terms of utility? Would this equipment require to treat an equal volume of contaminated soil compared to either phyto or air spudging or evacuation and taking to a site for thermal desorption? What is the cost benefits? Has that been done? Has that been considered? So why would I rather go for the microwave technology compared to the regular conventional ones? Then also, the last one is not a question, but it's an observation. So you mentioned that it treats to below 5,000 milligrams per kg. Just to point out that what the Gaspin refers to as 5,000 milligrams per kg is intervention value. And now intervention value is a value that once you attain, then you are compelled to remediate the soil. That's not the value we expect you to treat to. You're supposed to treat any contaminated sites to less than values that will support life, let me put it that way, or the values that you got, baseline values. That's what you're supposed to treat to. But once you get to 5,000, then you are compelled to. You have no case whatsoever. Exactly. So that's what 5,000 milligrams per liter per kg is. I just needed to point it out. So those are my questions for now. Thank you very much for the wonderful presentation again.
Yeah, thank you.
Section chair, your question, please.
So I think he should respond to the question just so we don't back.
Okay.
Yeah.
Okay, so you can take the first two questions, then we take the other two after you're done with this.
All right. Yeah. So for the first question about plant growth. Now, that's one of the major motivations with using microwave heating as an alternative to the conventional heating system. Now, in conventional heating system like thermal desorption, to treat the soil, you would have to raise the temperature of the soil to the boiling point of the hydrocarbons. And if it's heavily contaminated, you are talking about 400, 500, 600 degrees centigrade. And if in terms of incineration, you can go up to 800 degrees centigrade. And definitely at the end of such a cleanup process, the soil will be dead. But what microwave energy does is that because it uses a smart principle, it enables you to remove the hydrocarbons at a much lower boiling point. So you can get rid of hydrocarbons at even less than 250 degrees centigrade. Because like I said initially, it leverages on the moisture content within the soil. And you know, moisture turns into steam at just 100 degrees. And so as it turns to steam and moisture, which is being trapped in the soil pores, it forces it tries to force itself out of the soil pores, and in the process, it then strips off the petroleum hydrocarbon from the soil. So you can actually achieve the same process at a much lower boiling point. So which means that at the end, your plants, there are different works that have been done where they've demonstrated plant growth after using microwave heating system, when compared to the conventional heating system. So you have a better opportunity for plant growth, for the reuse of the soil after cleanup when you use microwave heating compared to the conventional heating system. And then also in terms of the second question that talked about like the energy usage compared to others, as well as the effort and the volume. If you follow clearly, I had actually talked about a few things, but I will add more in terms of, let me start with the energy. From the conclusions, you can see that I showed the comparison between microwave heating system and the conventional heating system. And amazingly, that reduces the processing time. Because you're using energy, it reduces the processing time by 90% compared to the normal thermal desorption process. And that means that an equivalent of energy you will use during microwave heating is much lower. And for the estimate of what I did in my work, it actually reduced the energy consumption or requirement by 1/3 compared to the conventional heating system, which is much more better. And just to give us a picture of the costs and benefit analysis carried out on some pilot scale by some different people in terms of the oil contamination for a certain treatment per ton, it costs actually about 14 to 23 roughly of pounds per ton for the cleanup using microwave. However, when you compare that with a conventional heating system, it takes about 169 to roughly about 340 pounds per ton of material being treated. And that is actually only limited to the fuel or the energy requirement alone in terms of the conventional heating system. Whereas the 14 to 23 pound per ton, a pound is roughly about 2,000 naira at the moment. So you can work out that math. So you can see that it's much more lower in treatment using microwave heating as compared to the conventional heating system. And when it comes to talking about comparing this with other things like phytoremediation, other things like bioremediation, if you look at it carefully, initially I started by saying that there is no one single solution that will be a one-size-fits-all for the problem within the Niger Delta. It has to be a combination of different technologies based on the nature and the type of contamination. And things like bioremediation, they're actually very good in terms of sustainability in the future, but they are not feasible for all types of contamination. If you have a very high level of contamination, it limits the effectiveness of things like bioremediation and phytoremediation. And apart from that, that takes a whole period of time to achieve. Some can last up to about 30 years to get a site treated by bioremediation or phytoremediation. But when you have high level of contamination, that is where things like thermal desorption and an alternative, which we are presenting here using microwave heating as an alternative to the thermal desorption. This is where they play their role. When you have high level of pollution where things like bioremediation might not be effective, then this will actually be a suitable technology approach for that purpose. Now, regarding the EGASPIN standard limit of 5,000, actually Nigeria doesn't really, or maybe I have not seen a particular standard that you have to drop the treatment to at the moment. I know like the USEPA from the US have their own standard limits. Now, this is like the rough idea of the standard that we can work with, that we've seen, that is actually published. And that's why I made reference to this amount. Of course, you've highlighted that you've expanded that this, when you reach this limit, it is mandatory to actually treat the soils, which is, of course, an important thing to note. So I just use this as a reference point, being the basic figure that we have in as a standard within the Nigerian oil and gas sector, basically. And so in terms of effort, this is an upcoming technology. These are new ideas that are being trialed for because of the potentials they actually offer compared to a more mature technology. So the thermal desorption is a more mature technology in the market at the moment. But actually, microwave stands to offer quite a lot if all the challenges of this system are dealt with and the processes are scaled up effectively. And the scale up of this process will actually not be an act by one single profession. It's going to be a combination of different expertise from process engineers, chemical engineers, electrical engineers, as well as electromagnetic experts. And also material handling experts, because we are handling materials, which in this case are soils. I'm not sure if I hope I've answered your question. Do come back if I've not, if I've missed any. Yeah.
Okay, thank you. So presentation pending possibility. I have concerns around where you were trying to place microwave in moisture
Yeah.
and then conversion to steam and the extraction of hydrocarbon.
Yeah, sorry, I'm not really getting you clear. You're not very clear enough.
Can you hear me now?
Yeah, good. This is much better. Yeah.
Okay, I said I'm having some concerns around
Okay.
where you said the microwave hits the moisture and it forms steam, and then the steam is able to take off some of the hydrocarbon.
Yeah.
When you put that vis-a-vis the boiling point of some of this hydrocarbon, and also know that there is a possibility of you to have materials of different boiling points that they will selectively boil and go off at their boiling point, at their respective boiling point. Are you saying I'm talking with the process through which steam which is a different how do I put it? You can have water in form of ice, in form of liquid, in form of steam.
Yeah.
Right. That is typically around 100 degrees centigrade.
Yeah.
Wouldn't that just be the removal of light hydrocarbon? If we have the heavier hydrocarbon at that 100 degrees centigrade, how possible is it that you remove those hydrocarbons? That's one.
Okay.
Then secondly, this process is limited to just the cleanup of soil, right? To be applicable by any stretch, pollution on water. And then finally, I'm just wondering if you have an entire community polluted, how do we put this into industrial use in terms of what do you do? Are you going to pick up that sand and transport to your industry? Are you going to just take a section of the sand? How are you going to effectively use that at industrial level? And what happens if the depth of pollution is quite deep? Does time come into view? Do you consider time in the equation that guides this process? I mean, the time of the pollution, a pollution that happened today and a pollution that happened that had been for 10 years ago, do they have the same effect? I'm sorry, I have several questions.
Yeah.
That's how much interest in your presentation.
Yeah. Okay. Can I respond to that?
Please, you can go on.
Okay. Yeah. Thank you. So in terms of the soil composition, now when I explained the principle, I talked about it leverages on the moisture that is trapped within the soil pores. Now, in conventional heating, you have to heat the soil material right up to the boiling point of the hydrocarbon to get rid of the hydrocarbon. And that is why you have to use very higher temperatures to achieve that. And in the end, it leaves the soil dead. Now, in terms of microwave heating, it heats the soil, the moisture within the soil, and it rapidly converts it to steam. Now, all of us know how steam tries to escape out of the pot. If you have steam trapped somewhere and it tries to escape, it's like it's flushing out itself out of that pot. So what it does is that it's like you are as it is like as it is going out of the pores, it strips off the oil that is on the soil. I'm not sure if you understand clearly my illustration. So the contamination that are on the surfaces and the pores of the soil are being swept along as the steam tries to escape. So the goal is not to raise the temperature to the boiling point of the hydrocarbon, but rather to leverage on the force that the steam applies as it rushes out of the pores. In the process, flushing out the contaminant on the surface.
So this is some kind of steam flooding.
Yeah. So it's called, we use the term steam stripping.
Yeah, because
or
this is the same thing that
entrainment.
happens when you do steam flooding in enhanced oil recovery. But go on.
Yeah, good. So that's the kind of the idea. We use steam stripping or entrainment to illustrate some of this mechanism. And then also in terms of if a community is polluted, like I mentioned initially, one of the advantages of microwave is that it has small plant footprint because of its high throughputs, which mean that you can actually have a mobile plant. So like the scale up that I showed initially, these are things that can be moved. This setup can fit into a container. You can fit a microwave process in a whole normal container, and you can take it to site, clean up that site, then move it to another site, clean up that site, move it to another site. That is the advantage of its smaller footprint. It can be a mobile, a kind of plant, a mobile process. And that's one of the advantages over conventional heating that has large capacities, and to establish that is going to take a whole lot of space, and decommissioning and moving it to another place can be an additional cost as well. So in terms of such a community, you just need to move the system to where the pollution is. You excavate the soil within that process. If you're treating it ex situ, you excavate the soil, you run the soil material through the microwave processing system, and you get your clean soil. Once you're done with that side, you pack the system again, move it to another side. So it gives you that flexibility in terms of process. So that's one of the key potentials of this technology. Like I said initially, these are pilot scale demonstrations. There are still studies that are going on to try to overcome some of the challenges that are limiting it from being scaled up. And I talked about one of those being the issue of thermal runaway, managing the temperature within the system. So in terms of deep pollution, microwave heating actually it offers a good advantage because if you're dealing with highly contaminated sites, that is where thermal technologies generally they perform best in terms of such types of pollution compared to other approaches. Because you can actually, in terms of efficiency, I'm making reference to that in terms of the efficiency, how much of the oil they can remove from the soil. So microwave will be a good, will have a good potential for sites that are deeply polluted, because of course you need to dig that site up and apply your microwave system to the soil that has been excavated, and then backfill it after remediation. So generally, thermal processes are really good in terms of their efficiency when it comes to high level of contamination, whether it's been there for several years or just for a few years. Whereas things like bioremediation and some of the remediation approaches would have a difficulty when it comes to high level of contamination that has happened over and over and over across several years. Yeah, thank you. I hope this is clear.
Thank you so much. Thank you.
Yeah, thank you, sis.
Engineer Rome, you raised your hands up. Still have a question to ask? Okay, want to confirm that everybody has gotten their question attended to. Jerome, your silence means, I guess, somebody has already asked your question and you understand what you wanted to ask. Thank you so much. Thank you so much, Dr. Diran Tangan. Thank you so much for your time. Thank you so much for, please, can we give him some virtual applause in the comment section? Can we celebrate him for taking time to answer all of the questions we all asked? We like to also advise that this is an opportunity to join SP. Dr. Diran, are you a member of SP?
No, I'm not a member of SP.
So, sir, section chair says that please, you should kindly register and be a member of SP. So, would that be done this month?
I need to understand SP better. I'm a chemical engineer, so.
Well, chemical engineer and chemical engineer, the essence of your work also speaking to valuation of petroleum and gas engineering too, right? So we are brethren in progress. So
yeah,
yes,
actually.
Yes.
Actually.
So our program chair and program chair two, the program chair two, the chemical engineer too, and we have several of them. It's not limited to petroleum engineers, right? If you have interest and around the value chain of petroleum and gas engineering, you are very much welcome. And I see you already doing something, telling us about KDA and PDA, which are oil polluted sites. So you see, you are in already. Thank you.
Yeah, thank you very much, sir. Thank you for the opportunity.
Okay, Secretary has already convinced you, so I don't need to say anything again. Thank you so much, sir. So on the screen, as the reasons why you should be a professional member of SP, discounted events registration for all of our events, and of course, we have student member benefits. To be a member, it costs 36,500 naira to be a member, and then the next year, 1 year after membership, you pay 69,500 naira. You can take a screenshot of the number on the screen. Of course, our membership chair will be most pleased to guide you on how to be registered. For those that are members, you can always send your payments to the account details on your screen, Society of Professional Engineers Abuja section, GT Bank, and of course, send the proof of payments to our membership chair, and he will fast track your renewal. We are live on all social media platforms like this event, and past sections are live streamed on YouTube. You can go back and refresh your memory. We are live on Facebook, LinkedIn, Instagram, X, formerly called Twitter. And of course, you can always send an email to spabuja-info@gmail.com, and in 24 hours, we will respond to you. We have a DL coming up, a distinguished lecturer program coming up on the 28th of May. It is an in-person event at PTDF Towers 2 Memorial Close in Central Business District in Abuja. We kindly appeal that you should register and of course come and learn from IT BAT. We also have two amazing events that will take place one in Abuja, one in Lagos, organized by the Nigeria Council. The first is the Africa Gas Innovation Summit. It holds from the 18th to 19th of June. It's a 2 days impactful technical summit on gas. So please visit our social media page. You can see the link here. Register today at africagasInnovationSummit.org/registrations. This is a free event. You should attend. And of course, we also have the Nigerian Annual International Conference and Exhibition called NICE, which happens in Lagos to take place from the 3rd to the 7th of August 2024. We have short courses. We have several packages for professionals. So please also register. Now, kindly note that we have an early bird registration rate. Early bird registration rate closes on the 30th of June. So please make use of this avenue and register at a discount. After 30th of June, it's going to get to the normal rates. Okay, at this juncture, ladies and gentlemen, I'd like to call our program's chair, Professor Kafayat Adeyemi, as she gives us a closing remark. Prof, ma'am.
Thank you, Akpan, and good evening, everyone. My sincere apologies. I had to join late. I was in a workshop and I couldn't make it out in good time. Thank you so much, Speaker for the Month, Dr. Direct. Actually, you show ATBU stuff, right? It's been an interesting and very engaging session. You could see from the questions that was coming in. Though I came in late, but I gained a lot from your presentation. So thank you very much. Thank you, section chair, for piloting the affairs of the section, and then to the board members. Thank you all for all your efforts to see that we keep pushing as Abuja section, and to all our participants. We thank you for taking our time to listen to this wonderful presentation. So wishing everyone a very pleasant evening. Thank you.
Thank you, thank you. Ladies and gentlemen, we've come to the end. Kindly turn on your video cameras. Let's have a quick snapshot. Please turn on your video cameras. Turn on your video cameras. Let's have a quick snapshot and see all of your amazing faces. Please turn on your video cameras. Okay. I can see our publicity chair. Thank you for joining, sir. Oh, our council chair is on the call. She joined quietly. It's celebrating, ma'am. Thank you for joining us. So, when I say SPE, you're going to respond with culture of excellence.
Akpan,
Yes, sir.
it will not be under my watch that council chair will be in a call and you will not greet her properly.
I'm sorry, sir. Ladies and gentlemen, my pleasure it is to most respectfully recognize the presence of the first ever female council chairman of SPE Nigeria Council, the first council chair, the first section chair, female, even from Abuja section director. Please, can we give her a virtual, in fact, a round of applause, please. Celebrate her. Thank you, ma, for joining us. Ma, any few words before we take the photo?
Good evening. No, thank you. I just couldn't resist taking the picture. I wanted to just quietly join and leave.
Good evening, ma. Welcome.
Good evening. How is Tanzania?